Yesterday I was supposed to complete by 1 o'clock, almost 60 students left. So I could have completed yesterday. Today I would have started RLC and we could have gone for problem. Almost by 1, almost the strength is declining. And I can block you who all lives without teachers permission. If you're living, no, I can block you. I'll block you for next class, because I'll be having all the information at what time students enters, for what time there is a loss of internet connectivity for you. So please do take care. So I know how to use good technology also. No, so there's an inductor. Now how the response of this will be like. So a current I will flow. Then the drop across inductor, we write VL equal to L di by dt. VL is nothing but equal to the applied voltage because they're parallel. This is the source, AC source. Di is equal to VL by L into dt. So what is VL? Should be equal to V naught by L sine omega t. Let me integrate this. Di is equal to so this will be I is equal to V naught omega L cos omega t. So the denominator, I'll call that as inductive reactance, where XL is called as inductive reactance. And what it does, it will react. It will react. So what can be unit for inductive reactance? Ohms. So again, from basic Ohm's law, current equal to potential difference by the resistance. No. So what is the unit for inductive as well as capacitive reactance? It is the ohms. So what is XL? XL equal to omega L, and omega, you know, 2 pi f. Like this, what happens? The reactance offered by the circuit depends on frequency. Okay, let's see what is actually meaning of this. So yesterday, what we have plotted the graph, no? No. This is at any time t. I'll put small graph. Like yesterday, we have calculated power, everything, no? So everything has to be plotted here. No, this is the first the applied signal sine omega t. The applied signal is sine omega t. Next, what we have is cos minus cos omega t. So this is the current and this is the voltage. Look at now. So it is current lags the voltage. So therefore, I'll give a name. I'll call this as lag circuit. And RC circuit is called as a lead circuit. I don't change the convention. Even in exams, you need not to say RL circuit or so like I just call this a lag circuit. The reason for that is current lags the voltage here. Time being, okay, later on in the RLRC will give the name. So here current lags the voltage. You should not say, sir, voltage leads current, so therefore it can all be also lead. No, the reference is what? With respect to voltage, the current lags. And then what about the next? We'll go for the power. So this is about the XL is inductive reactance. So what it does, it will just see that the inductor, what it will see, it will make the current to lag the applied voltage. That's what the reactance I brought it here. So let's go for the power calculation. So P instantaneous is equal to V into I. So what is V? Vm sine omega t. This is V naught and this is I naught cos omega. What is I naught? I naught will be V naught by XL. So this will be V naught I naught by 2 sine 2 omega t. So what is the average power? Should be 0 in one full cycle. Then when I plot again the graph, similar to RC circuit, what we did. So it should be the this is what first negative means it will accept energy from the source or it will draw energy from the source. Negative means first it will draw energy from the source, then it will return. So like this, the negative, positive, we'll put it here. And what is the average power? Average power will be 0. There's an expression for instantaneous power. So therefore, what is the inductor? Inductor is an element which will not consume power, but in fact what it offers to the circuit, it will make the current to lag the voltage. Able to get this one? It will make the current to lag the voltage. So that's what the inductor does here. And whatever the capacitor, current will make the current, capacitor what it do, it will make the current to lead the voltage. So negative is what we have here, minus V naught cos omega t. Okay, let's get into the, so there's about, so is it inductor consumes any power? No. And there'll be exchange of energy between the inductor and source in one cycle. Twice it will occur, no? You can say that. Simplest questions, capacitor inductor will not consume any power, yes, but will offer some phase change between the current and voltage. Is correct statement. Huh? Theoretical questions also can be asked, you have to be careful. This is about the R, L and C
Sir,
individually.
sir, how do we know that current is maximum at t equal to 0? We got expression V naught by omega in cos omega t.
The moment you switch on, there'll be current, no? What is there? Connect one ECM meter. Finish or no?